The One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. One Africa TV. It just gets better.
We are still busy with trigonometry. Today we're going to combine trigonometry with algebra. But let's just go back to our rules that we know up to now. In the first place, we look at a right-angled triangle. And there we have learned that we have sine theta, which is opposite over hypotenuse. We have cosine theta, which is adjacent over hypotenuse. And you have tan theta, which is opposite over adjacent. SOHCAHTOA, to remember. Then, which method? Top times, bottom divide, and to find the angles, it's always the second function. Then we worked with any triangle, not a right-angle triangle. There you can use the sine rule, which says A over sine A is equal to B over sine B. We use this when we have opposite sides and opposite angles. The next one is the cosine rule. The cosine rule is to find the third side. You want to find the third side. And then it is B squared plus C squared minus 2BC cosine A. Again, the angle and that side correlates. Then we also have finding the angle when you have three sides. And this is then this formula, B squared plus C squared minus A squared over 2BC. Again, the side, you subtract the side which is opposite the angle, the wanted angle. And the last one is then the area formula, which says half BC sine A. Okay, so now we're looking at try now 42 on page 488. You have a right angle triangle there. This one is x plus 4. Actually, this side there is y. Now, it starts there by saying the area of the triangle. So that is what you should work with. Remember, you have to show that. You may not use that. You must show that. So I know this is a right angle triangle, so I now know area is half base height. So 48 that was given is then a half of x times x plus 4. That's where you're going to start. I will get rid of this fraction here, LCM, so it is then 96, and I'm going to multiply this in here, so then I have x squared plus 4x. Look there, they're on the left-hand side, so you have to bring them over. Negative x squared, negative 4x, plus 96 is equal to 0. And then we have to show that we're dividing this by negative 1. You can either do it like this, or you can write here divide by negative 1. And then we have x squared plus 4x minus 96, which is equal to 0. So that's then number A1. This is then A1. Then they say solve this equation. And we're going to solve this with factorization. So it is x and x, which factors of 96, if you subtract it, will give you 4. And it is 8 and 12. Signs differ. The biggest combination This one is positive and this one is negative. So x is equal to 8 or x is equal to negative 12. X is equal to 8 or x is equal to negative 12. And then now at number 3, we have to find AB, this side. We choose this one. This is the correct answer. And plus 4, so the answer would be 12 centimeters. 12 centimeters. Right, now we're looking at number B. Number B says tan y is equal to 1 over 6. And we have to calculate the value, find the value of y. We have to find that y first. So this is going to be second function, y, 1 over 6. So second function tan 1 over 6 is equal to 9.46. So the angle is 9.46, 9.46 there. And then they say when the length of AC is 9, so this is now the hypotenuse, this one is now 9. And then show that you can get that. And now I'm going to use Pythagoras this time here. So I'm going to say now that x squared, sorry, we're going to use Pythagoras, plus x plus 4 squared, I'm using Pythagoras, is equal to 9. So the square root of this is equal to 9. So to get rid of this square root, I'm going to square. So then you still have x squared plus x plus 4 squared is equal to 81. To get rid of the square root on that side. Now I'm going to solve it here. Remember, this means x plus 4 times x plus 4. Don't leave that step out. Then you're going to make mistakes. So it's x squared plus 8x plus 16, which is equal to 81. And now we can just bring that one over here. I have 2x squared plus 8x plus 16 minus 81. 16 minus 81 is equal to 65, negative 65. And at number 2, they say now again, solve this equation. And look what they say there. Show your working, give your answer to 2 decimal places, which means that this is going to be with a formula. I hope you can still remember what we were doing. So x is equal to, what was the formula? Negative b plus or minus b squared minus 4ac over 2a. So look how they combine the algebra with trigonometry. This is what we're looking at specifically today. So if I substitute now, it is negative 8 plus or minus negative 8 squared minus 4 times 2 times negative 65 over 2 times 2. So we do this with a formula. The next step is then negative 8 plus or minus, and we have to find the value there in the root. You have to find that value in the root. So it is then 64 plus 4 times 2 times 65, and I have 584 here in the root. Make sure that you get that right. And then we get the 2 answers from there, and x is equal to 4.04, or x is equal to, we're still finding x here, negative 8.04. And again, obviously, we're going to choose this one, 4.04. Yet they just asked you to solve it. So now in the next step, we're going to use this value because this is the positive value that we want there. They asked the perimeter here. So now it is x plus 4, which was now 12 plus 4, and plus the 4.04, and the final answer is then 21.8 that you have there. Right, the next one is try now 43. Try now 43. So here we combine the the bearings here with a, so this is also a very nice question that we have here. This angle is 40 degrees, there's a 95-degree angle, 12, 10, 30, and 17. And the first thing that we always look, is it a right angle triangle or not? And this is not a right angled triangle that you have here now. So we start off with A. Calculate angle CAD. Angle CAD, this one. So we can use the sine function because you have opposite sides and opposite angles there. We want to find the angle. So sine A, and this is opposite the 10, is equal to sine 95 over 12. Can you see? Opposite sides, opposite angles. That is what we're going to use there to calculate that one. You want to find the angle, so it will be second function, your answer. And I got 56.1 degrees. It's necessary that you first do the exercises and then mark them. Right, then B. Now we want to find BC. So this is this length that we need to find here. This is not a right angle triangle. So I'm going to want the third side. So I'm going to use the cosine rule. So it is 17 squared plus 12 squared minus in brackets 2 times 17 times 12 cosine 30 degrees. Cosine 30 degrees. And I got that BC, remember it's not BC squared now anymore, is 8.93 meters. Now we're looking at number C. Find the bearings, and this is specifically what we want to look at now here when they have those bearings also there. B from A. Now B from A is this one that we want to find there. So we've got that 40, we have this 56.1, and this one is 30, so we can just add those three angles there, and I have 126 degrees. Remember, bearings are not to decimal places, they are three-figure bearings, so you have to give it like that, as a three-figure bearing. Then the second one is A from B. Now, A from B means this is what I want. I'll have to draw a north line there and north clockwise. That is what I want to find out then there. So this one is then 180 degrees, that straight line there, plus the 126.1, because remember, those angles are alternating. This is the unrounded one that I use here, but my bearing is 306 degrees. And then number D, now we have to find angle ACB. ACB, this is now what we want. They say it is an obtuse angle also there. And what we actually have to calculate is BCD. BCD. So this is what we want eventually. So ACB is 72.14 degrees. I calculated in that triangle then there. If it is obtuse, it is obtuse, it is 180 minus that one, which makes it 107.9 degrees. Can you see? Remember cos that we worked with. And then ACD is then 180 minus 95 minus that 56.1 degrees. So that one is 28.9 degrees, ACD. And then we come to BCD. As you can see, it's quite a long one, and it's that 107.9 degrees, that obtuse angle there, plus this 28.9, plus the 28.9, and that is then 136.7 degrees. Good morning, grade 11s. This is then the last exercise now on trigonometry combined with bearings. Next week we'll write a class test and eventually an achievement test. Make sure that you understand here. So we have to look, is it a right angle triangle or not every time? So we have these P, Q, R, and S, the ferry points. A ferry is a ship which carries cars and stuff like that. And it sails from P, stopping at Q, R, and S before returning to P. There you've got the idea there. Now, the first place, the question is, show by calculation that angle QPR is equal to 55 degrees. So my first question is it a right angle triangle? Yes. Which function will I use here? And I can use tan. So tan P is equal to opposite over adjacent. Opposite over adjacent. To get the angle, it's second function tan. Remember that you will use brackets there, and my answer is then 55 degrees. First do the exercise, then you mark it. You will get that on the calculator. Number 2. Write down the bearing of R from P. The bearing of R from P. Now the bearing of R from P is this one. R from P, north clockwise. I know now that this angle is 55 degrees. I know that this is a straight line. So what I need to find is this little angle first, and then I can add it to 98 degrees. So it's just 180 minus 98 minus 55, and that will give you R from P. Yeah, well, on the other hand, we can just subtract this 55 degrees also. Perhaps that's easier, and it is then 125 degrees, that bearing then there. Number B. Explain, so the bearing of S from R is 98 degrees. There you have it. And SP is 13.5. Explain why angle RPS is 27 degrees. So this is now the 180 degrees minus the 55 minus the 98 degrees, and that is how we get the 27. This is good enough for an explanation. You don't need to write more words or whatever. That is good enough here. And then they say angle PRS is 90 degrees. Calculate the distance RS. Calculate the distance RS. So this is a right angle triangle again that I'm using. I know that this angle is 27 degrees. Which function will I be using? Sine. So sine 27 degrees is then equal to RS over 13.5, which is the hypotenuse then there. And then which method? Top times. You will just multiply the two then there, and I got 6.13 meters. 6.13 meters. And then finally, find the total distance of that the ferry sails. That's right around PQRS. You just add all those sides, and it is 37.13 meters. That's then the total distance. Right, question 2. In the diagram, BCD is a straight line. It's a quadrilateral that you have there, and with all the information. Right. So in the first place, they say calculate BC. Again, is it a right angle triangle? Yes, it is a right angle triangle. So I can say, which function will I be using? Sine. So sine 30 degrees is equal to 15.7 over BC. Which method do we use now? Divide. 15.7 divide by sine 30, and that is 31.4 meters. 31.4 meters. Number B. Use the sine rule, so they tell you what to do, to calculate AEC. This is what we want to calculate now here, and show that. You may not start with that. Show that question means you have to get the answer then there. Using the sine rule will then be sine E over, which side is opposite this one? 15.7 is then sine 52 over 16.5. Then we cross multiply now here. You want the angle, so it will be second function, your answer that you get there, and we get then 48.57. Actually, you should first write the unrounded answer there. So 15.7 times sine 52 divide by 16.5 is equal to, and then second function, your answer. That calculator doesn't work like that. 15.7 times sine 52 divide by 16.5, and then second function sine, your answer is, so I got here 48.5734. Because it's a show that question, we have to put that step in, and it's then 48.57 degrees. Then it will round off like that. The next one is now number C1. Show that angle ECD is 40.6. Now ECD means this is the angle that we want to calculate now there. This is now not a right angle triangle in that case there. So show that the angle is 40.6 correct to one decimal place. Number C1. Right, so to get that angle then there, it is in a triangle, so it will then be 180 degrees minus this 48.57. It's just it's no calculation then there, minus the 52 degrees. And that's how we get what they gave you then, 79.53. Okay, and then we can say that in ACE, in this triangle now there, it is 180 minus 60 minus that 79.53. Remember they said it was a straight line, so that's why I just subtract them there, and we get 40.57, which rounds off to 40.6. So that's how we get that 40.6 there, just working with the triangles then there. Then number C2, now they want us to find DE. They want us to find DE. Let's look again at the sketch. So this is what we want to find now here, DE. And I use the cosine rule here. DE squared is then 16.5 squared plus 23.4 squared minus in brackets 2 times 16.5 times 23.4, and the angle that we are using is cosine 40.6 degrees, the one opposite the side. So DE is then equal to 233.5006. I get the square root of that, and the answer is 15.3. 15.3. And then the last question is now a question on the area. We're working there with the area there. Calculate number D, then calculate the area of the quadrilateral ABDE. That means you're going to have to calculate the area of each one then there. We first need that the length of AB to get that area there, because it's then half base height in that right angle triangle. This one is 27.19 meters, AB, and then I calculate the two areas. Then I calculate the two areas there to add it. So it is then, you'll have to add those areas. So it is a half of 27.19, because those two, they must be perpendicular. That's why I need AB, and the 15.7. This is in a right angle triangle. And then the second one is now not a right angle triangle. So it's a half BC, 15.7 times the 16.5 sine 79.46. Remember, two sides and the included angle. And then plus the third triangle, which is not a right angle triangle either. So it will be 16.5 times 23.4. And the included angle then there is sine 40.6. Make sure that you take two sides and the included angle every time. Then there. And the answer is then, for the first one, 213.4 plus 127.3271. I don't round off now. I round off in a final answer, 0.631. And then if you add the whole lot, it rounds off to 466 square meters. Square meters. Right, very nice question then there. And let's look at the last one, number 3. There's my triangle. In the triangle, QPR is acute. We've got those sides. And the key sentence now again is here. The area of the triangle is 48. Is this a right angle triangle? No. So we'll use the formula half BC sine A. So a half of 10 times 14 sine P, because that's what you want to calculate now, is equal to 48. I equate to that one. And then now with algebra, second function, then we get that this one is 43.3 degrees. That P. Show that. You'll have to put those extra steps in because it's a show that question. And then the last one says, calculate the length of QR. This is the third side, so it will again be the cosine rule, which is then 10 squared plus 14 squared minus in brackets 2 times 10 times 14 cosine, and I'm going to use this angle now, which that is why you had to show that question in the previous one. And my final answer is QR is equal to 9.6 meters.
loves football on GoTV, so he traded being a best man for being a best fan. Miriam stood her date up just for this matchup. Albert and his family had plans, but they couldn't miss this, and neither can you. Because this new football season, this is football worth watching. Get a GoTV decoder and 1 month of GoTV Max for only $349 to get all the football action. GoTV, live it, love it.
Your achievement test on trigonometry. Congratulations, there's a lot of you who did very well and you understand it, what we've been doing. The nice thing of trigonometry is that there's formulas, and if you apply the right formulas, you can get good marks. There are also learners who don't understand. You'll have to watch the videos again. There are some of you who get mixed up with right angle triangles and any triangles, so you totally didn't use the cosine and the sine rule. But there are also learners who struggle with sine, cosine and tan in right angle triangles, and you still choose the wrong ones. Please listen carefully now here and paste your test in your test book and do the corrections in your test book now there. Right, question 1. Now, obviously, this is a right-angled triangle here that we have here. Write down the length of BE, extremely easy. This is going to be 10 centimeters. We just add the 2 there. Then calculate the length of AB. This is now a right-angled triangle. And for the third side, we always use Pythagoras. So that will then be 12 squared minus the 10 squared, which is equal to 6.63. Look at the rounding. We said right from the beginning last year, we round off to 3 significant figures. If it's less, you're going to lose the mark. It must be 3 significant figures. Number C, calculate the size of AEB. This is the one that we want to find now here. You can use different functions depending on your choosing the right sides here, which ones you want to use. I prefer to use given information, but it doesn't matter. So I used cosine. It's the included angle here that I want to calculate. So cosine E is then equal to 10 over 12. Look at your mistakes. Some of you swapped the two. Some of you have chosen sine here. Look, it's the included angle. You should be able to identify it. And that is then 33.6 degrees. 33.6 degrees. Then the length of CD. Now, this is now in this triangle. So we're asking ourselves which function, if you look at the angle, this is the opposite, this is the hypotenuse, so it's going to be the sine function. So sine 30 degrees is equal to the 6 over CD. Now look there, which method? Bottom divide, because it is that hypotenuse that you want to calculate. And that one's answer was 12 centimeters. And then, so very, very easy. This is really a grade 8 question. What is then the size now of D here? It's a right angle triangle. Angles add up to 180 degrees, so it's going to be 60 degrees. Very easy. Question 2. The angle of elevation from the boat. This is the angle of elevation upwards. is 35, and the boat is 1,210 meters from the foot of the cliff. Calculate the height of the cliff. This is what we want to calculate. Which function? It's tan. This is opposite. This is adjacent. So tan 35 is equal to the opposite over 1210. Which method? Top times. You just multiply the 2 there, and I have 847. I rounded it off there to 3 significant figures, 847. Then the angle of depression. What is the angle of depression? This is this angle, eye level downwards. And now these two are alternating. So very easy. The answer is just 35 degrees. 35 degrees. Now, the last question, number 3. This is a little bit more difficult, and here was a few problems. When we do this, and how will I know? This is the indication, because they say between 0 and 360 degrees. Then we work with cast. You will remember the lessons on cast. This is where all sine, tan, cosine is positive. This is the meaning of cast. This is where they are positive. And then we also had what we call the butterfly story. And the butterfly story is, how do you get that angle now? And this one was 180 minus theta. This one was 180 plus theta. And this one is 360 minus theta. So that's what you need in a question like this. Now, let's take number A. Sine alpha is equal to negative 0.707. Now, the negative indicates the quadrant. It indicates the quadrant, so you shouldn't press that. So second function sine 0.707 is then, it rounds off to 45 degrees there. So where is sine now negative? This is the question. So draw. I don't see that you draw that indication there. So if sine is positive in all and sine, it means this is where it is negative. This angle of 45 degrees is your key angle. It's not part of the final solution. It's your key angle. This is the two angles that we need to get. And how do we get them? Butterfly story. So this one is then 180 plus 45, which is 225 degrees. And this one is 360 minus theta, which is 315 degrees. So actually you should write final solution, and this was the correct answer there. That was your correct answer. Now let's look at number B. So we can say that tan alpha is equal to 4 cosine 35.3, and this is not difficult. You just press your calculator and you get a value there. I take the 2 over and I divide by the 3, algebra. This is algebra. And then second function tan, we press it and we get 1.754. This is the calculation here. This is actually still tan alpha. And alpha, second function tan now, is 60.3 degrees. Now we have to draw it because it's between 0 and 360 degrees. And the question, according to cast, is where is tan positive? Because this is positive. And it is in those two quadrants where tan is positive. So this angle is then 60.3 degrees. And how do I get this one? Butterfly story 180 plus, and that's then 240.3 degrees. So you got a method mark here, and then for the two answers. And here you got a method mark there, and for the two answers. We should still look a little bit at cast. I think there's still a lot of you who struggle with this one. Right, question 4. A 4-meter long ladder leans against the wall. The foot of the ladder is 1.4. This is grade 9 work. Pythagoras, to get the third side, we find Pythagoras. So it is 4 squared minus 1.4. And I subtract because I want the other side. You add if you want the hypotenuse. So we just press the calculator. 3.75 meters. 3 significant figures. You have to round off to 3 significant figures. Bearings is also still a problem. 20 and Sipu walks towards each other. 20 walks on a bearing of 40 degrees north clockwise. Find the bearing on which Sipu walks. Now, this is the bearing that we need to find north clockwise. This one is 140 degrees because it's parallel lines there, co-interior angles, but that's not what you want. You want this one. So it is 360 degrees minus 140 degrees, and my answer for that one is 220. Very few had it correct. Question 6. Now, is this a right angle triangle? No. It's not a right angle triangle. So now you're going to use those other formulas, the cosine rule and the sine rule. P is 63 kilometers from O on a bearing of 23 degrees. So that angle there is 23 degrees. And this one is 170 on a bearing of 77 degrees. So that angle there is 77 degrees there. So we need to find this angle here, which is then just 77 minus 23, and this angle here is 54 degrees, because you need the angle inside the triangle. Now we have to calculate PQ, and can you see third side? Now it's the cosine rule. Now we know this is the cosine rule. So that will then be 63 squared plus 120 squared minus, in brackets, 2 times 63 times 120 cosine, and which angle are you using? 54 degrees. So you get a method mark here for substituting correctly. And some of you do that and then you just leave out the question. You don't go further. So we need to find the value of PQ. So you do that calculation, and then we have to get the square root of that one. I have here 9481.68, and the answer is then 97.4, rounding to 3 significant figures. Look there, there's a minus in between. Some of you ignore that. I don't want to mention names now. And some of you put a sign in here. Make sure that you know the formula. You are going to get it. Now we have to calculate the acute angle PQO, which is now this angle that we want to find now there, PQO. Now I can use the sine rule because I have opposite sides and opposite angles here. So we can say that sine Q over 63 is equal to sine 54. And now we're using that side. Here you'll have to use the unrounded information, the unrounded one. Otherwise our answer is not correctly. And then to find the angle, it's a second function. So second function Q, this is actually Q, is equal to 31.6. Some of you used the cosine rule for the angle, finding that angle then there. And then you got here a difference of 33.6. I've calculated it. So that was then also another method, and it is correct. Another mistake that some of you make is to write here at the sides also sine. You've got double signs there. Please look at those mistakes. And then the last question here is the bearing of Q from P. Now the bearing of Q from P means I want that angle. That is what you want. So we can calculate now here the third angle. having that one, so that's 94.4. And we can find this angle because it's parallel lines again there. That one is 157 degrees. So now to get this bearing, it is 360 minus that one. And then I have 109. Remember, if they ask bearing, it must be a 3-figure bearing, no decimal places there. Question 7. This is also not a right angle triangle. That's the first question that you should ask yourself. So this is on a bearing of 64 degrees, 140 kilometers. This angle here is 125 degrees. And now the question that they ask us, find the bearing of S from R. S from R means that is what we want to find. That is what we want to calculate there. So it's precisely like the previous one. We can first find this angle. It's parallel lines. So this angle is 116 degrees. And then there's a revolution. So it is then 360 minus 116. You should get a mark for that 116 minus 125. And the bearing is then 119 degrees. Then calculate the distance between T and S. Which formula will I use? Third side, so it's again the cosine rule. So number B is now going to be TS squared, which is then equal to 140 squared plus 128 squared minus, in brackets, 2. Look at the minus there, 140 times 128 cosine 125 degrees, the included angle then there. So T is equal to, you need to get the square root of 56540.97. I don't round off already. And then in a final one, it's 237.78, which rounds off to 238 kilometers. And then they ask angle S, RST. So now we need to find this angle here, RST, and I will use the sine rule. Opposite sides, opposite angles that I have there. So for number C, we can say then that that is sine S over which side is opposite, 140, is equal to sine 125, and this is opposite this side, which we have calculated now there, so I put it over 237.78. The unrounded one, you do cross multiplication, second function sine, and this angle is 28.8 degrees. 28.8 degrees. And our last question, is this a right angle triangle? Yes. Now I have a right angle triangle again. Calculate the bearing of C from B. Now what would be the bearing of C from B? North clockwise. Again, we can find this angle. This one is 90 degrees, so it's 360 minus those two angles. This one is 159 degrees. So you're going to say it's 360 minus 159 minus the 90 degrees, which is 111 degrees. That's your bearing. Then BAC. BAC, so now we're working in this triangle. There's the triangle. So my question is, which function will I use? Now, this is the angle, and this is the two sides, so it's cosine. It's that included angle. So cosine A is then equal to 82 over 173. Second function cosine to find an angle, and it is 61.7 degrees. Then number B, the hot air balloon, which is hovering at E, is vertically above C. Now we said draw the little triangle. This is those three-dimensional ones. Draw the triangle so that you can see where is your 90 degrees. And the 90 degrees will be at C, isn't it? And there's the balloon at E. So this angle here, the bearing there from D is 35 degrees. There's D. And we have to calculate the height. We have to calculate the height. And we know that this side is then 82. You must draw the picture. Then you can see what to do. So which function will I use to get this one? Tan 35 degrees is then equal to EC over 82. Which method? Top times. And the answer was 57.4 meters. And then the last one, number C. Now you have this bird above the field at a height of 40 meters above the field. So there's the 40 meters. It spots its prey on the ground on an angle of depression. Now, where is that angle? Here's the bird. Here is the bird flying. There's the bird. So the angle of depression is here, 63 degrees. That is outside the triangle. So you need to find one inside the triangle. So there's the 63 degrees. And now they want to calculate the distance that the bird has to fly. So here's the mouse that it spots. And this is the distance that it's going to fly. So if we label it, this is opposite and this is hypotenuse, which makes it sine. So sine 63 is 40 over the hypotenuse. Which method? Bottom divide, and the answer is then 44.9 meters. Right, grade 12s, those of you who didn't do well in the test, please look at the mistakes. Trigonometry is also a topic that we're going to use in grade 12. It will form a very important part of your syllabus. Worksheet on trigonometry now. This is a final worksheet to make sure you understand what we are doing here on trigonometry. So the first question says, Charlton is on a bearing of 125 degrees north clockwise thereof Elisa, and Elisa is 325 meters due north of Brandon. Due north means straight north then there. Calculate the bearing of Elisa from Charlton. Now remember what we said with bearings, that it's always north clockwise. There's a lot of you are still forgetting these things. It is north clockwise. Then whenever you have to give that bearing, it should be a three-figure bearing. It's not just degrees like 14 degrees. You will write 014. That is a three-figure bearing. And then the other thing is from. You're looking at the from angle. That is where we are measuring. So this is now, the question is now the bearing of Elisa from Charlton. And Elisa from Charlton is this. This is what we want to calculate there. North clockwise from Charlton. That's what we're looking at there. Now, we're using the fact that these two lines are parallel lines. That's a very important step there. Which means then, if this angle is 125, this angle here is going to be 55 degrees. So this is co-interior angles. You can also calculate this one to be 55 degrees, and then they are alternating there. So to get that bearing, it is then 360 minus the 55 degrees, and your final answer is 305 degrees. This is also a three-figure bearing. That's what we have then there. Then they say calculate the distance between Brandon and Charlton, the length of BC. So this is a right angle triangle. We first always look if it is a right angle triangle or not. And then we know that we can use Pythagoras here. So it will then be 630 squared minus 325 squared. And the answer is, remember, we use extra brackets there around them. And my answer is 539.7. And then we can always round off to 3 significant figures, which makes it then 540 meters there. So this was now bearings, but it was also a right angle triangle. Question 2. Now here they combined algebra with trigonometry. Clever question here. They tell you what to do. Use the cosine rule to find an expression for AB and simplify that expression there. So I must use the cosine rule, which says then that AB squared is equal to y squared plus y plus 2 squared minus, in brackets, 2 times y plus 2, and then the angle here is cosine 120 degrees. Cosine 120 degrees. And press your calculator to get a value there, and you will see that this is then actually negative a half. Cosine 120 degrees is negative a half, because that will make it much easier to solve this one now there. So now we can say AB squared. Now I'm going to work here. This is y squared. Plus, remember, this means y plus 2 times y plus 2. Grade 11s, it's very important that you will first do the worksheet on your own and then mark it. Otherwise, it doesn't help. It is then y squared plus 4y plus 4 minus, okay, now I'm working in that bracket then there. Now, what I'm going to do is I multiply this negative half with this negative 2, and then I actually have positive 1. So they're going to cancel out each other. So then from there, we just have y squared, just multiplying that one in. Remember this, and this will now cancel out then there. So it is y squared plus 2y. And now we can just simplify this whole one, because that's what they say, and simplify. So this is 2y squared minus y squared. No. Yeah, actually we should remove this negative also there, because we've multiplied the negative with the negative there. So then we have 3y squared plus 4y, no, plus 6y, 4y plus 2y, and then plus 4. That's then the simplified expression. Now here at B they tell you AB is 7. So now I'm going to square that 7, which makes it 49. So then I have 49 is equal to 3y squared plus 6y plus 4. If I bring it over now, it is negative 3y squared minus 6y minus 45, which is equal to 0. No, plus 45. And then if I divide everything by 3, show